But why do the most pronounced geodynamic processes occur specifically at the edges of this vast block? The answer lies in the way the plume intrudes. It softens the underlying asthenosphere. Picture a dense, monolithic structure, beginning to experience pressure from below, not uniformly, but in distinct pulsations. Even a slight uplift in such a plate results in the greatest deformation at its periphery. Its outer edges begin to quite literally rock. Seismic data analysis from 1990 to 2024 clearly reveals spikes in seismic activity along the perimeter of this block. Across the Urals, the Baikal region, the Verkhoyansk Fold Belt, and most notably, in Kamchatka. This activity occurs in wave-like pulsating bursts across different regions, resembling a gradual rocking of the plate from the west to east and from the north to south. It is precisely along the edges of this colossal block that the most dramatic geodynamic processes are unfolding, such as in Kamchatka, which lies at the very margin of the continental crustal block, now under pressure from the plume. Kamchatka is also part of the Pacific Ring of Fire. Seismic data from 1990 to 2024 show that the Kamchatka and Ural Islands region is not only experiencing the gradual trend of increasing seismic activity seen throughout the Ring of Fire. There are also distinct independent spikes in activity. This indicates that the Siberian plume exerts its own direct influence on the Kamchatka region as the terminal edge of the continental crustal block subjected to its pressure. Particularly telling are the changes in earthquake depth. In the Ural-Kamchatka region, anomalies in the distribution of earthquake depths point to increased mobility at the lithospheric plate junction, another direct consequence of the Siberian plume's influence. The Kamchatka earthquake on July 30th is a direct result of this process. The irony lies in the fact that the magnitude 6.0 earthquake on July 20th, cited by Verkhoyansk, did not relieve the accumulated stress, as some scientists believed, but instead served as a precursor to a far more powerful event. So what actually happened? In truth, we are witnessing a classical manifestation of the pulsating nature of plume intrusion, in which seismic activity predictably intensifies around the perimeter of the affected zone, culminating in the plume's eventual surface breakthrough.